Charles Darwin once said that light will be thrown on the origin of man and his history, and that light is now here from an unexpected source, our DNA, and the DNA of ancient humans that lived and died long before us. Paleogenomics is the study of ancient DNA to see how different species have evolved over time. The science allows us to peek into the genetic makeup of extinct animals, including extinct species of human. Throughout the 1990s and into the early 2000s, the field exploded as better tools and techniques for sequencing DNA became available. But in 2010, the potential for paleogenomics to revolutionize our understanding of ancient humans and ancient human evolution, it became undeniable. Just 7 years after sequencing the human genome for the first time, a team led by Svante Pääbo published the groundbreaking genome of a Neanderthal, an extinct species of human. But that's not all. The genome showed clear evidence that our species, sapiens, had hybridized with these Neanderthals. It was a revelation that truly opened an entire new story into the history of us. Ancient DNA opened a new window into our past, giving us tools to study the story of humanity at a detail that we never thought possible. But it didn't just add details. In many ways, it challenged old ideas. For decades, scientists had debated one of the biggest questions about our species, about us. Where do we come from? I'm going to read an excerpt from a paper that was published in 2001 just to give a quick idea of what this debate was so that we can understand the two sides and their claims. There are two major theories in this regard. The first, often referred to as the multi-regional hypothesis, argues that modern humans evolved in different parts of the world from earlier local populations. For example, Indonesian Homo erectus is thought in this scenario to give rise to the living populations in Australia, while the Chinese fossils are regarded as ancestral to modern Eastern Asians. The alternative theory, known as the single origin hypothesis, argues that living human populations are descended from recent migrations of Homo sapiens, probably out of Africa, who subsequently replaced existing groups such as Homo erectus. So to make it simple, just to break it down, side A, the multi-regional hypothesis, they thought that Homo erectus long ago had left Africa. Some stayed in Africa, evolving to sapiens in Africa. Some, like the erectus of Java, evolved into the people of Australia. The erectus that was out in China evolved into the modern-day Eastern Asian populations, and Homo erectus in Europe evolved into European sapien. Very deeply divergent evolution of these populations that were loosely connected over time through some interbreeding. While the single origin side believed that our species, sapiens, originated in Africa and then left Africa more recently, replacing those other human species that had been out in East Asia and up in Europe, meaning all modern humans today came from that population that was in Africa and some of them had left. The ancient Neanderthal genome effectively broke both models, leading to a new understanding of out of Africa. Both models had parts that were wrong. For example, multi-regional suggested that people in Australia, they had evolved from a different population of Homo erectus than people in Africa.
For Professor Walpoff, only the Indonesian Homo erectus can be the true ancestor of the first modern Aborigine populations.
The idea was mainly based on skull morphology, and skull morphology can be helpful at times, but it can also be really misleading. Humans have been moving around for a really long time, and skull morphology has evolved many different ways, and in many ways convergently over time. So, looking at that one thing, it doesn't tell a whole story. DNA, however, DNA can tell a lot about a story. And DNA has proven definitively that modern humans in Australia, they are the same species as the modern humans in Africa. The two didn't evolve from a different population of Homo erectus. The two, they are divergent by less than 100,000 years, so it doesn't fit the model. I'm gonna fact check myself real quick. I mentioned in the video they last shared a common ancestor less than 100,000 years ago. I was thinking about like Eurasian populations with the Australian populations. If we're talking all humans going back to Africa, 125, 130,000 years. I'll pull this paper up, but this is a really good recent reference for that. While DNA did conclusively debunk the multi-regional model, the single origin model didn't escape unscathed either. The key missing piece, the piece that became clear after Pabo's team sequenced that Neanderthal genome, was the hybridization. The single origin model of 2001 claimed that sapiens, they left Africa and then they replaced all of those other species. They were gone, vanished. We outcompeted them. None of their DNA would persist in modern day sapiens. But we now know that's not the case. We do have admixture from Neanderthals. We have admixture from Denisovans. As our species met these other species, oftentimes we did interbreed. We did hybridize. And because these other species had been out of Africa for a long time, adapting to their more local regions, they had traits that would be beneficial for the sapiens that met up with them and interbred. The key missing piece, the piece that became clear after we sequenced the Neanderthal genome, was the hybridization. And the hybridization seems to be substantial in ways, but minimal in ways. So what does it mean towards this old debate? The old debate, the single origin hypothesis, the single origin model, it suggested that sapiens, less than 100,000 years ago or so, they successfully left Africa and then they replaced all of those other archaic populations. That is what happened in a way, but because that hybridization occurred, some of the DNA from those ancient species still persists in our own genome. So both models had flaws, neither was perfect, but you often see the multi-regional model being brought up on the internet, at least I do, to support the idea that out of Africa as a model has been debunked. And the reason that is so believable is because of this admixture, because of this hybridization. When you only account for the hybridization, yeah, it does make it seem like we have a multi-regional evolution. But when you think about what that multi-regional hypothesis, that multi-regional model was, it was talking about populations that had diverged back in the days of Erectus. That's not what happened. Instead, what the evidence shows is that our species, we did originate in Africa, and then some populations left Africa with success 100,000 years ago or so. By 60,000, 50,000, 40,000 years for sure, those populations had spread into Europe, China, Australia, and they had met up with other pockets of humans, interbred with them, and essentially absorbed them. Why did we absorb them? I don't know for sure, but it probably has something to do with population dynamics, our social structure. Evidence suggests that Neanderthals, for example, they had lower diversity. They seem to have lower population sizes, and that makes sense because they were dealing with the extremes of the ice ages. It would have been hard to support as many people, whereas in Africa, genetic evidence suggests that we didn't really live in super isolated pockets. Instead, there was a really interconnected web. So once you have a species now spreading throughout the rest of the world that has an entirely different population structure and has much larger numbers, it's easier to see how those small pockets of humans could be absorbed as this other species spreads. Which one was right? Neither was completely right. Single origin was mostly right. It just didn't account for the fact that we did hybridize with some of these other populations after we left. But today, when we look at humans, we're like 95% sapiens, and that's being conservative. Most people don't have 5% admixture from other species. Most people, it's going to be more like 2 or 3%. So, in my opinion, when those are the numbers, it's clear that sapiens originated in Africa, left Africa, met up with some other populations, but when you ask where we came from, it's still Africa. Now, I get it. I'm just an ex-science teacher. I don't have any degrees related to this stuff, and when I've made videos in the past that took on people like Robert Seffer, I got a lot of comments pointing out the fact that I'm not an expert, so why should they believe me? I learned from past videos, and I talked with one of the leading experts, Dr. Chris Stringer, and I'll go ahead and play that too, just to kind of add a little bit of, hopefully, credibility to this video, I guess you could say. from what I've gathered over the last few years, because again, I'm not an expert, I'm just a teacher that really got interested in this, is that it seems pretty clear that you've got our divergence between us and the group that would go on to become Neanderthals and Denisovans probably over 500,000 years ago. In Africa, we kind of have this interconnected web where it's not really one location, but just populations across Africa, kind of like Africa's multi-regional hypothesis almost. And then there are potential little waves, little sparks that almost make it out of Africa, but don't seem to lead to anything. And
Yep.
then eventually there is a wave out of Africa after a potential standstill at some point. They eventually make it out and they start spreading into regions like China, Europe, Australia. And
Yeah.
it's true that they pick up admixture from other human species that were evolving in those regions. So in a sense, we do have some of that
Yeah.
ancestry, you could say, but it's very much mostly out of Africa in the sense of like our
Yeah.
species started in Africa and then left, some of
Yeah,
them.
and that's the summary term I use now. I talk about mostly out of Africa. That's my way of describing it now. And I think it was Fanti Parbo. I used to say largely out of Africa, but now mostly out of Africa sounds better. And that was Parbo, I think, first used that. So that's how I describe it now. I don't know whether you've seen my Huxley lecture from the end of 2023 that I did for the RAI. That's on YouTube.
This is the so-called out of Africa model. And Chris Stringer was one of the architects and originators of this model back in the 1980s. At the time, it was controversial, radical, and strongly opposed. He was not, however, a dogmatic defender of the faith, and it is one of those signals of his strength as a paleoanthropologist that he was almost always the first to see how the model needed adapting in the light of new evidence. Mostly out of Africa.
When I started making this video, my expectation was that I was going to make a video explaining the history of these two models and where things stood today. But by the time I got to the point of watching this back, it became clear that this became a video essay over why, when we ask where our species originated, the answer is still Africa. It's a topic that really I think is so interesting, but it's been co-opted by these people with narratives that want to push the idea that our species didn't come from Africa, and they will take the nuance of this debate, the debate I just went over, and they will use it to mislead people into thinking that scientists now don't think Africa is where our species came from. I want to give a special thanks to Chris Stringer. If you want to get a more detailed explanation of all of this, go watch the video he suggested at the end of our discussion. You can go, it's so much more, but I just wanted to make this shorter. I really am happy with how it turned out. If you liked it, make sure you like, subscribe, share it with people. I'm trying to grow this channel. I really enjoy doing this, but as you can see and probably tell by the flickering light I'm dealing with right now, I got a ways to go. This current semester I'm substitute teaching, so it's like the perfect chance to try this out, try to jump into this. I had tried it once before, just I didn't have time between teaching and having kids. It wasn't working out. So I'm trying it this semester. Like, subscribe, share. It means a lot. Thank you, Professor Chris Stringer. Thank you for coming on and just explaining some of this stuff to me, answering questions I had, really helping me go into this video with confidence.